Hey team, this is video 9. As I promised, this is going to be an RStudio video almost entirely, in fact, entirely. So please open RStudio at this point. I'm going to go ahead and do that also. Let's see if I get my fun bug. I don't. It just opened. It's a genius machine. Okay. So here you can see that on the left-hand pane, I have the console all the way up to the top because I don't have a file open right now, but I'm actually going to ask you to open up you can open up a new R script, yes, by going here. There's a paper with a plus sign, grab it, pull it down, R script. And then you should get a script window to open up. Yes? Yes. Okay. So this is going to be a practice session where we look primarily at functions that help you describe your data set. And there are several of those. So I'm going to call this practice2.r. You may have practice1.r, and you can continue to use that for practice, but I think I want to make a new words. I think I want to make a new practice file for this particular moment. You know this already, but recall that the hashtag is a comment character. It just tells R, skip that line. So the front part or the top part of your R script should contain a preamble, and all the lines of the preamble should have comment characters. So, for example, the name of the file, your name, the date, it's October 6th, how, October 6th, 2019. Oh, and I'm going to go back up here and add another line, comment character. I want to say practice reading data and summarizing data. The best practice when you're writing a preamble is to always have at least the file name, the name of the person coding, that's me or you, and a very brief description of what this file does. So there it is. That's my preamble, practice2.r. Now I'm going to go and do save as. I am going to save it in my, where did I put it? Do I not have it? Oh, so sad. Let's look. Current courses, quant methods, lectures. Guess what? On my laptop, I don't yet have a PSI 232 folder. So I'm going to go ahead and make one within my quant methods folder. I'm going to call it PSI 232. Create. There it is. And I'm going to go back up here into the dialog box. It has an untitled file. Remember, we said we'd call it practice2.r. Okay, save. All right. I also noticed that if I don't have a PSI 232 folder, if I didn't have a PSI 232 folder, then I probably also don't have counties.csv in that folder. So let me do a little bit of magic. Going to my Finder, find counties.csv. Well, that's interesting. There's no counties.csv here. Guess what we have to do? We have to download it. Everything is terrible. Okay, let's download it. For those of you who still haven't managed to get this part done, I have great sympathy for you because clearly I haven't exactly either. You can follow what I'm doing, and maybe that will be helpful. So I've connected to Drexel. I'm a faculty member. Woohoo! I'm going to go to the Blackboard page. There it is. I'm going to look under data. I'm going to scroll down to the county data. And I'm going to control, click, save, link, Oh, interesting. Doesn't like that one. Let's see what happens if I open it in a new tab. Hey, if I open it in a new tab, it just goes where I want it. It just saves it. That's really nice. So current courses, quant methods, PSI 232, counties.csv, save. Hopefully that worked. We'll find out in just a moment. All right, back to RStudio. If you, unlike me, are a well-prepared student, you have a default working directory set to your PSI 232 folder. You have counties.csv downloaded into your PSI 232 folder, and you also have installed the tidyverse such that you can use the tidyverse. And with that, we're going to start coding. So I'm going to look up here and say library tidyverse. Library is the function that makes a package available to use. Yeah. Save that. And again, a couple of you asked about this in class. This top left pane, the script window, is for stuff you're going to save. If I were just noodling around in the bottom in the console, I wouldn't be saving my work necessarily. I would just be kind of trying things out. And you can feel free, by the way, to just do this in the console if you want to do that. I prefer scripting. I prefer using the script window for a variety of reasons, not the least of which is that it's really annoying if something goes wrong to have to retype every line. With scripting, you can just go back and fix the thing that's wrong. All right. So line 6, as you can see in my script, is library tidyverse. And the next thing I'm going to do is a thing you've already seen me do. I'm going to make a new object called cnty for county. And I'm going to read underscore CSV. And then with quotation marks, they can be single or double, but they have to be there. I'm going to read the file that I want. But first, I realize I'm looking here. I don't know if you can see. Looking here next to where it says console, it says, guess what? You're not in your PSI 232 directory. So I'm going to change that using setwd in the console because I won't need to put it in the script. So I know from this that I'm in my home directory and I want to be in my PSI 232 directory. So what I'm doing is typing the first few letters and then hitting tab, and then there's my PSI 232. Okay, and you can see now it shows me that I'm in my PSI 232 directory, and that's good. Because that is where the script is saved, and that is where the script will look for the file that I'm trying to find. And let's try and find it. Let's see if, yes. So what I did there was type COU tab, and that shows that I'm in the right place because tab auto-completed it. Remember that in line 6, tidyverse is an object because it is a package that is installed. And so it doesn't need quotation marks. However, counties.csv is a file name, and therefore it needs quotation marks. So let's see if this first bit actually does the job. So we're going to go up here and hit the word source. Yep. There it is. It gave me this long ass description of what's in counties.csv. So it says parsed with column specification, and then it lists a bunch of the columns, and then it says, and 24 more of them. Yeah, you're going to put up with this cold too. Okay. So the things I want to do today involve the following. I'd like you to be able to figure out the size of your data set. For the moment, I'm going to switch down here to the console. So I'm going to move this actually up a bit so that you'll be able to see what's going on. So here we are. I'm now in the console, recall, and I want to ask how many rows and columns are in this data set. So there's a very easy way to do that, which is ncol, the name of the data set. So there are 124 variables. Awesome. How do you guess you find the number of rows? That's right, nrow. Whoops, not nrow. nrow, CNTY. 3,143, and that is correct. I happen to know because I made this data set that it has 3,143 observations of 124 variables. So again, ncol and nrow are really simple functions that can be quite useful if you're not kind of sure what you're looking at. And they both just take a data frame or a Tibble object as their argument. Another way of finding out how big your data set is, and actually basically doing both ncol and nrow at the same time, is is dim, and that's short for dimensions. Dim, CNTY. There you have it, 3143 by 124. So, for example, one thing we could ask R, is nrow CNTY equal to dim CNTY 1? It is. That's good. If that weren't true, something very strange would be going on. But let me tell you what I just did there. So you know what nrow county is. That produces the number 3143. You know what dim county is. That produces two numbers. So a vector of length 2. There we go. That produces a vector of length 2. And the first one, by convention, is the number of rows. So when we want only one thing from a particular vector, we use brackets, those things. So the number of rows in county is 3143. The first item in the dimensions of county is also 3143. So when we ask, is it equal? That's what we do with double equal. We're asking. It says true. And that's really good, because if that weren't true, we'd be really screwed. I wouldn't have the first idea how to fix that. All right. The first thing I want to do, or rather the next thing I want to do, is look at a couple of other sort of description functions. One of them is length. And let's first I'm going to just type in CNTY and return, and it's going to give me a brief description of the whole data set. So scrolling back up, you can see that CNTY is a Tibble with those dimensions. Here are the first 10 observations of the first few columns and a list of the remaining columns. That's really long and annoying, but that's what it is. What I want to do now is use the function length. Length says, how long is a particular thing? It has to be a one-dimensional thing, so it has to be a vector. And in this case, since we're looking at a data set, a vector means a column, or potentially a row, but let's call it a column. Okay. We're going to ask for the length of CNTY, and I want the length of the vector of the column total population. I'm going to go down to top pop. Hey, what do you know? There's that 3143 again. So length is not ridiculously useful for columns. It can help us figure out if if there's something really wrong, if one column is short, etc. But better is to, showcase length by going like this, 1, 2, 3, 4, 5. And then the length of X is 5, right? Simple, but occasionally really useful. For example, there's a function called unique that tells you every unique value in a given vector or a given column. I know. I know. Sometimes we want to know how many possible values there are, right? We would want to know, well, is this something with a huge number of numerical values or a small number of options? So, for example, and in that case, right, if we just used unique by itself, so here's unique CNTY $. I'm going to go with rural urban 2003. You can give it anything you want. I'm going to go like that. Those are the unique values of CNTY rural urban 2003. Now, if you had done something, if you had used a character value or a larger or a less constrained numerical value, you'd be getting a giant of values. So, for example, let's do, because we hate ourselves, just kidding. Let's do unique values of total population, shall we? Oh no, right? It tried to give us every unique value of total population. That's not super useful to me. And in fact, it can't do that because looks like there are too many of them. That's what reached get option max print means. But what we can do is find out the number of unique values by saying length unique CNTY $, top pop. Huh. So that is almost the same as the number of rows, which makes sense, right? Because we wouldn't expect many US counties to have exactly the same population. All right, fair enough. So that is length. You may also use the function summary. So let's do summary. Here I am doing, again, I'm taking summary as the function, and the thing I'm taking a summary of is a vector or a column, and in this case, county $ total population. So hit return, and you get this nice little summary. The minimum number, the smallest county by population terms, has 83 people in it. The mean county has about 98,000 people in it, and the largest county in the United States, I'm going to say that's LA County, is 9,830,420 people. That's a lot. We can also, if something is a numerical, if something is a continuous variable, or in some cases even a count variable, it can be useful to look at a histogram. The function hist also takes a vector or column. Hey now. There we go. So this is just a kind of look at the distribution of counties in terms of their population. Not a very informative distribution because most counties are quite small and only a few counties are enormous, but that is something you can do. So that's what the function hist does. And notice that when I'm doing length or unique or length unique or summary or hist, all of these take the same kind of argument, and that is a vector or a column of a data set. Okay, last but not least, I want to show you table. Now, table you have to be careful with. Much like unique, table will produce an enormous list if there are a lot of values of something. So I'm going to scroll back up and look here. Well, I'm going to scroll way back up and look at rural urban 2003. Now, that only has, I'm literally counting, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 unique values. I'll use that as my example. So table tells you how many observations have each of the unique values. Let's do an example. CNTY rural urban 2003. There it is, in order this time. You'll notice that the NA is missing. That's because, unlike a lot of the functions we use, table takes an option. And an option is something, it's like an extra argument that you can use but don't have to. In this case, that option is use NA equals, and I use the word in quotation marks, always. I always want to see how many NA, that is missing, values there are. So then we get that. And it weirdly came out formatted a bit differently. These are the exact same values, but one of them has an NA on the end. And we can see that for whatever reason, there is no rural-urban classification for 57 US counties. Who knows? I have no idea. So it tells us roughly that there are a lot of highly urbanized counties. That's 429 highly urbanized counties, 396 entirely rural counties, and in the middle, actually, is a 5. So that's like, it's not half and half. I'm not sure how they make that ordinal scale, but that's actually the lowest number at 104 counties. In any case, that is what table does. And the cool thing about table is that it can tell you, it can do that for a combination of as many variables as you want. So I'm going to do another example with table, only this time I'm going to give it 2 columns. We'll say table, county, rural, urban, 2003, comma, CNTY. How about bad housing? Bad housing is, I believe, we'll find out, a binary measure of, you know what? I don't think that's true. Let's do this. Let's do CNTY rural. Yeah. So rural is a binary measure of whether something is rural or not. You'll be shocked to hear. And when we hit return on that, I want to add that option. So you can now see table is the name of the function. It takes as many arguments, where the arguments are columns, as you want, although I typically don't recommend more than 2. And then it also optionally takes that use NA equals argument. Oh dear. Turns out rural is not a binary measure. I was just wrong. Let's go back and see if we can find a binary measure to use. Let's see. CNTY. Let's see. How about bad housing, bad water, uninsured? Okay. I'm going to go ahead and not do this part because I think what we will do instead is in class, we will make a binary variable. Dang it. And I will show you how to do that using if else. If else is a function that is incredibly valuable to people who are trying to binarize data. You can go ahead and noodle around in practice2.r if you like. Again, the functions that I hope you learned are ncol, the number of columns, nrow, the number of rows, dim, the dimensions, length, summary, and table. Optionally, you could think about the function unique. In class on Tuesday, we're going to talk about if else, and we're going to revisit these other things. Okay, thanks very much. See you soon.